Welcome to Cheese Code by Roman Dmitri. Today I have a visitor named Polio. He's one of my cats. Hi, Polly. Polly's a really good boy. Today we're continuing the Monorepo. Specifically, we're adding a Postgres database with a Phinx migration. So as you can see on my screen, there's a couple new services that you haven't seen yet. Number one is stubb-psql. We'll talk about that first. That's the Postgres database. It's got a Docker file with some tools and it's pretty straightforward. The second is stubb-phinx, and that's the PHP migration tool. There's a specific reason why I use this one instead of something else. I'll also briefly touch on stubb-go and show you a proof of concept from the Golang container into the Postgres service. So as always, let's first do a boot and just see how long that takes. What you're seeing now, or saw for a split second, is the Phinx migration container waiting for the stub Postgres container to start. If the container Polio. If the container isn't fully started, then we'd get a Phinx error, and we don't want that. So I have ran this multiple times. I have all the dependencies already, and it took only 8 seconds to start, which is still pretty good, I think. Remember, we're only running a single command and the entire system works, and it actually ran the database migrations too, so I'll explain those in a sec. You'll notice that we only have the stub Postgres container here, and we don't have a stubb-phinx container. That's because the stubb-phinx container only runs momentarily to run the database migrations, and then it shuts down. I've just scrolled up a little bit, and here's the output from the Phinx migrations and the status report. You'll see that I have two migrations, one for creating an alpha table and another for a Bravo table. That's just there to show you that it works. Having said that, let's get started. Let's look at stubb-psql first. Okay, so here are my changes, and here's stubb-psql. High level, we have a docker ignore file and a regular git ignore file, and then we have our compose Docker file, make file, and readme file, as well as some scripts. A lot of this should be following the same pattern that you've already seen in the previous videos. The readme file is quite minimal, and you can just check it out on your own because I'm actually going to talk about everything right now. In the make file, you'll see a pretty standard local bash suffix that I use to get into my containers. You should have already seen this in the React and Go services. The command that we're really interested in is local connect, but first let's just look at Docker Compose and see how everything fits together. In the Docker file, we simply specify we're using a Postgres image, use any version that you want, and then as always, I add some of my own favorite dependencies here. As far as the permission stuff, I'm just skipping it for now because we're not really writing anything from the container. I did try this, but I ended up with some permission issues. Specifically, I believe the Postgres container runs under a different user, so I just need to figure out who that is. In the Docker Compose file, we're loading the Docker file that I just showed you, and we're kicking it off with the Postgres command that loads a Postgres config file over here. I'm going to skip ahead, but the Postgres config file is actually mounted from right over here. And the reason we do this is because I want to override the Postgres configurations. And the one I'm trying to override specifically is the one called enable sequential scan, and I set that to off. The idea here is to prevent Postgres from going to a sequential scan even though an index exists because the table has a low number of rows. In other words, Postgres by default will do a sequential scan if you don't have enough rows to meet the criteria of the index. It actually thinks that a sequential scan's faster. But when you're doing local development, how do you know if all of your indexes are working as expected if Postgres is going to try to do a sequential scan? Well, one brute force approach is to just fill your database with a lot of data and hope for the best. but that's kind of, I don't know, counterintuitive. I think a more appropriate way to do it is actually just disable the sequential scan. And then, I won't show it in this video, but typically I write my code that calls the database to actually run the same query twice. First the original query to get the data, and then run an explain analyze on that query and check if any sequential scans were executed. If sequential scans were executed, I'll actually throw a warning or even an error. This way, nothing gets through to production unless it has an index. Success. Right? We're just trying to be all that we can be. So let's aim for the skies. Next, scripts. Script folder, just like everywhere else, except in here I have a function that's called connection string that will just put together a connection script that will just put together a connection string from our specified environment variables. These environment variables specifically come from our Docker Compose file. And if you read the image for Postgres, so the image is specified here. So why don't we actually just click on that. Okay, so check this out. This is the image for Postgres. And if I scroll down, blah, 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 I will eventually find a section on environment variables that explains to me how to specify the Postgres password, the Postgres user, Postgres database, and a whole bunch of other flags. Well, essentially, I'm doing that in my Docker Compose file and setting everything to Postgres because this is just for local development. Obviously, don't do this in production. So where was I? Right, so the connection string in the utility function, these variables come from here. And they are also the same variables that the image requires to actually create the Postgres server. Success. So we're mounting the configs and we're running them here, just talked about that. And then we're mounting essentially the entire folder into, the entire service folder into a /source folder so it's accessible in the container if we need to use it for whatever reason. Actually, that's basically it. You'll notice that I don't have any migration files in the database service, specifically the stubb-psql service. The migrations are actually in the stubb-phinx service. So let's look into that. So here's stubb-phinx. There are many migration tools, but I use Phinx because it's capable of handling very complex scenarios or scenarios where you're working on a team with multiple developers that are creating database migrations, and those migrations are created in a different order than in which they are merged and deployed to some sort of cluster. So essentially, if I make a migration on time point 1 and a team member makes another migration on another branch at time point 2, but they merge their code first and then push that code to a cluster, both migrations will still be eventually executed. I have seen migration packages such as the go-migrate or go-migration package, which actually just pushes you to the latest timestamp and it doesn't bother checking to see which migrations previously ran. That for me simply does not work. It creates all sorts of issues and sometimes they're difficult to solve because, oh, I expect this change to be here. Why is it not in the cluster? Forget all that. Phinx will take care of it for you, but there is kind of a penalty that you have to pay. And that penalty is that it needs to run in a PHP container. And because of that, we have to, well, if we really wanted to, we can install PHP in our Postgres container, but I like to keep things separated. So I made a separate service/container that has PHP and Phinx installed in it. And that's what we're looking at now. So quickly, docker ignore blank, well, actually docker ignore skipping vendor folder, and git ignore is skipping the vendor folder. The vendor folder is the equivalent of node modules for node, except vendor is for PHP. Same as your package.json file, we have a composer.json file that will specify the packages that we need. And specifically, it's the Rob Morgan Phinx package. I'm actually not even sure if it's been updated in a very long time, but hey, it still works, so who cares? In the Docker file, we do quite a lot, but we start with the PHP image. We, download Composer, which is the equivalent of Node Package Manager, but for PHP. We get a whole bunch of other fun stuff. We get a Postgres development package because Phinx needs to use that as the driver adapter to connect to the Postgres database. Then we have to unzip it, specify Postgres as a PHP extension, and do our regular gypsy magic with permissions here. But after that, we're basically set up. So let me show you the make file. We first have our regular bash to just get into the container, but this will be kind of like a run wrapper. You'll see all of these are run wrappers. So reminder, this does not run through Docker Compose. This kind of runs on its own just through a one-off Docker image. And it really has, well, two primary purpose and one side purpose. So the side purpose is just to make sure that all of the dependencies are installed during that initial boot up script. But then our primary goals are to have a create command that lets us create database migrations and a migrate command that lets us actually execute those database migrations. So to get Phinx to work, you have to have a phinx.yaml file. I've actually just made a folder with a local and a cluster file. We'll just look at the local file for now. And here I'll specify the same username and passwords that we specified in the image. In the cluster version, you'll see that we have these values that we can override later in our CI/CD pipeline. But you'll also notice that at the bottom, I specified that we want to use this template file when we create our migrations. And that's because, again, it's a PHP package and it's quite powerful with whatever it does with PHP. But ultimately, we just kind of use raw SQL at the core of it. I don't use the up or down or sideways or upgrade or whatever commands they might have. I don't use their ORM style syntax. I don't want to learn it. I want a migration manager that can simply use raw SQL, do what I want it to do. I'm not afraid to learn that stuff, and neither should you be if you're at all. The closer you can get to the truth, the better developer you're going to be. So anyway, here I have an alpha migration and a Bravo migration that I believe I already showed at the beginning, but if not, I'll show you in a minute. In our scripts folder, we have the create script, which essentially is a wrapper for the Phinx create command, and it's using our local YAML file and putting the migrations into the migrations folder. The install script, similar to the React and Go scripts, basically runs the package manager with the install command. And the migration script first actually waits for the Postgres container to start. This is using our utility function called waitFor, which actually uses a wait package. I encourage you to follow that and look it up on your own. But once we know the database container has started, we run the migrations and then we spit out the results. So let's show you what that looks like. Make stubb-phinx local. And again, I'm tabbing to complete, and I already know kind of the make target here, but it's create table Charlie. That's the kind of command we want to create. And what you just saw is that the Docker container spun up, ran our create script, and created this file as a result. And that happened in about 0 seconds, which is dope. So if I go to my unversioned files, you can see that it's actually created a class structure with the same name, and all I have to do is fill in the middle here. Create table Charlie. We'll just make it an empty table, but this will work. So let's collapse that. And now if I want to run the migrations, I can just run migrate, and let me zoom out for a sec. And now it ran the migrations, which is pretty sweet. But how do we test that this works? Well, one thing that we can do is I can open up my IDE, go into the database settings and show you there. But since I need to prove to you that the stubb-go container can also connect to Postgres, why don't we do that instead? Before I go in there, I just want to show you that I've added the Postgres client into the stubb-go container, just so it's available for me to do this demonstration. But now that I'm in here, I can simply run the PSQL followed by a connection string. The connection string, it uses the Postgres protocol right there, uses Postgres username, Postgres password, and connects to the stubb-psql container using the actual internal port, not the external 1232. So I've connected from the stubb-go container. That's already a success. And if I ask for the table listing, here they are. Alpha, Bravo, and Charlie, the one that I just created. Success. Guys, that's pretty sweet. I think we're done here. I've now added a database container to our Monorepo, and well, it works as expected. So you can use the code for your reference. Again, this is version 0.3.0, and I'll be merging that into the main branch shortly. Guys, thanks for watching. I hope you found this informative. If you have any questions, comments, concerns, leave them down below. In the next video for this series, I'll probably focus on creating a versioning script that will update the versions across all of our services, so I don't have to manually do that every time I create a branch. You'll know what I'm talking about when we get there. Thanks again, guys. Keep learning. You're awesome. Polio's a really good boy.